Well, hello there. My name's Bob from Bob and Dang's Journey. Welcome to our YouTube channel. Today I'm going to walk you through a 12-volt conversion of Starlink so that we can run Starlink from our camper using our 12-volt system instead of having to run the inverter. So we don't normally do a lot of these how-to videos here. This is in fact the first one we're putting out. But I thought this would be something interesting for our viewers. A few of you might also have Starlink and be interested in how you could do this. So anyhow, let us know in the comments section if this is something that's of interest to you or not. Maybe we'll do a few more once in a while. All right, let me start by telling you I'm not a professional and I don't work for Starlink. What we're doing here is just based off of research that I have done. I feel pretty confident about what we're going to do. And we're doing this to improve our lifestyle as we're traveling. If you choose to do this with Starlink yourself, you need to take responsibility for that, do your research, and be comfortable with the process. So if you've watched our videos, you'll realize that quite often we're boondocking in remote locations. And frequently those locations don't even have cellular connectivity. So this is where Starlink really comes into play. We're able to use that in places where we would normally not get any network connectivity at all. In my job, I'm required to be available 7/24, and therefore having Starlink is a requirement in these locations, and also having it running 7/24 is a requirement. So currently, in order to have Starlink running 7/24, that means I have to run my inverter 7/24. And that's an inefficient process. This is going to convert DC voltage from the house batteries to AC and then back to DC. So there's a loss there. And in addition, I have a travel router that I tend to use anyhow, so I don't really need the router functionality from Starlink either. So this is where the 12-volt conversion process is going to come into play. By doing this, we're going to eliminate the need to have the inverter running 7/24, and that's going to save us quite a bit of power and also just make things in general easier to set up. I've seen some other videos on YouTube and some blogs and other articles on the internet that talk about converting 12 volt. None of those did it exactly the way I wanted to do it or that fit my use cases. So I thought I'd make this video and throw one more out there in case it happens to match the way you need it done. There's also been a few new components that have been released in recent times that make this a little bit easier. In the past, people have gone to modifying the Ethernet adapter that you can purchase from Starlink, or maybe modifying the cables themselves directly. And one of the things that we wanted as part of this process was to leave the Starlink stuff intact, completely stock. So this will have the benefit that in case something does fail in the piece that I'm making now, we can simply go back and revert to the stock Starlink. There won't be any problem, no reconfigurations or anything necessary. So before we jump into actually making the replacement, let's take a look at what Starlink provides first, and we'll walk through what you get with Starlink and what each component does. All right, so the first thing we have here is your Dishy, right? Everybody's got one of these. This is the real brains of Starlink. This contains the communications with the satellite. It contains the positioning hardware. So there's a lot going on inside the Dishy here, and this requires power to operate. It requires 48 volts in particular to operate the circuitry and the servos here in the dish. This is provided through the proprietary Ethernet cable that Starlink uses. So effectively, you've got a cable with proprietary ends here, one that plugs into the router and one that plugs into the dish itself. And this cable is essentially just a Category 5 shielded Ethernet cable with the proprietary ends. Then finally, you have the router. And the router is just basically, its job is twofold. it is going to connect to the Dishy through the cable, and that's how it communicates with the outside world. And it does its router thing, which is to provide Wi-Fi and translate that over into the satellite feed. And then the other thing that it provides is power. So this injects power through the Ethernet cable so that Dishy has power to operate on. And this is what we're going to be doing today, is replacing this router. We really don't need this piece in our world. And because the router only has 120 or AC input, we really want to get rid of that component there and replace it. So I'll show you what we're going to do with that. So let's take a look at what we're going to need to complete this project. I've put links in the description for all of the things that I purchased. Pretty much everything came off of Amazon, so it's easy to get. In addition to that, I will say that I'm starting out on this project new now, so I don't have history with all of these components. I've done some research and I feel like these are good components and they'll work. But if for some reason there is a problem down the road, I'll update this video or make a new video with an update on that. Hopefully that won't be necessary. This is an RJ45 to Starlink proprietary connector. And this is something that is fairly new on Amazon. But it makes life easy, and this is what prevents you from having to modify either the Starlink Ethernet adapter or the cable itself. You can see it's got an RJ45 port here, and then here it's got a proprietary Starlink connector. So this is the same type of connector as would go into the router. So this is what we're going to be using to provide RJ45 to Starlink. Now note that this expects power over Ethernet to already be present on the RJ45 connection on the correct pins. So we're going to take care of that with some other components. Okay, you're going to need a 12 volt to 48 volt step-up transformer. This is going to ensure that the power that you have on the house side, which is a 12 volt battery, that's ours anyhow. If you run something different, you might need something different for that. It connects to your house here, 12 volts, outputs 48 volts here, and this is going to be fed into the power over Ethernet converter. So here we have a PoE injector. So what this device does is it takes an RJ45 Ethernet connection without power over Ethernet, and then it's going to allow you to get power over Ethernet out of this other port, assuming you apply power to these connectors here. So you can see that these just are standard kind of screw-on connectors here, and you feed it in power, and whatever power you feed it in, as long as it's within specs, it's going to apply to the Ethernet cable. And we're going to go into a little bit later more detail on PoE standards versus the Dishy standard, because they're not the same, and that's part of why we're having to do this work here. Anyhow, this is the power over Ethernet adapter here. You need a switch as well. You need to be able to turn power off to the system when it's not being used, and you also want to make sure that you turn power off whenever you're connecting the cable to either the dish or to the adapter that we're wiring up today. Those things have 48 volts on them, and those connectors will arc occasionally, and that can degrade the connection. So anyhow, I bought this one on Amazon. It wasn't very much. It has a nice light here, so when it's on, it'll light up a green color. Easy to see where it is. Finally, I'm just going to put this little inline fuse in it. This takes just those, I forget what they are. They're just the automotive style fuses. We have a lot of these in the trailer already, so I always have spares of those. And I think I bought these by the dozen off Amazon. They're cheap. You just cut the wire here and then put it in line. So this is what's going to come off of the battery before it accesses the switch. Okay, you're going to need also some shielded Ethernet cable. The cable that Starlink uses is all shielded, and I think that's going to make it more resilient to, possibly having some problems with crosstalk with other electrical components, etc. I just bought this Cat 6 shielded cable off of Amazon. I think I got a 14-foot version. I'm going to end up cutting off about 1 foot of this, and as you see later, we're going to have to do some rewiring. This is probably the most complicated part of the whole project, but it's not terrible. We'll get to that in a bit, but you're going to need cable, and it's going to depend on where you're going to place your router and where you're going to place the components that we've just talked about. So you're going to need a board or a box or something to mount all this equipment in. I just had this 3/4 inch plywood lying around, so I cut it down to a spot that's going to fit well for me, and painted it black. This is going to go in the RV and the pass-through near the water and cable hookups. There's a nice place I can feed the Starlink cable up through there, and this is going to work fine in that environment. You're going to need some cable connectors as well. These are going to fit onto that Cat 6 cable that I bought. These are shielded pass-through RJ45 connectors, and this is going to be useful for, we're going to have to do some custom wire routing there, so these are pretty cheap on Amazon as well. You're going to need some power cable as well. This is just going to be something, in this case I'm using 16 gauge. What you use might depend on how far you have to run it. I don't have to go very far to get power into this from where it's going to be mounted, but you will need that. I do recommend getting pure copper if you're going to get this stuff rather than copper coated aluminum. Not very good. And you're going to need various other tools. I'm not going to show them here, not tools, but pieces that you can crimp the power together with, etc. We'll go over more of those when we're actually doing the install, but these are the main components that you're going to need. Finally, you're going to need a router to replace the Starlink router. This could be almost anything. I've been using this for a while now. This is GL iNet. This is, I think, called a Barrel. It's a little travel router. It's nice because it's got some built-in firewalling capabilities. It's pretty configurable. It can connect to a phone's hotspot, so it can be a Wi-Fi repeater, or it can take a WAN port and connect that way. It's also got the ability to connect via USB tethered mode, so it's quite flexible in what it can do, and they're not terribly expensive. And really what I like about this is it draws very little power. It's powered from USB and doesn't use much power at all. So it is only Wi-Fi 5, I think, which is fine for the speeds that we're operating at, but you can put any kind of router you want in here. This is just the one we happen to have and the one I plan to use. Okay, so there's a few other tools that you're going to need. Mostly you're just going to need standard stuff that you might have in your toolbox already. You've got a screwdriver, you're going to need that. You need some pliers, dikes, something like that. I use these wire strippers here. They work well, but you could get by with literally anything. There's those little red-handled ones that are really inexpensive, will work just fine too. And then probably the only thing close to a specialized tool would be something like the Ethernet, the RJ45 crimp tool. So this one I bought off Amazon. This is something that can both cut the cable, but also this one is specifically set up to deal with pass-through connectors, and that's what most of the Cat 6 shielded connectors I found were made of. So I ended up getting this one. seems to work okay. One last thing before we get started. I made this little diagram, and I find this is useful to kind of plan things out, how things are going to put together. So let's walk through this a little bit and review what we're doing here before we actually get started. We start with a battery, which in our rig is a lithium iron phosphate 12-volt system. They actually produce more like 13.3 volts. From there, we go to the 15 amp fuse. That feeds into our switch. And the switch powers the step-up transformer, which provides the 48-volt power to the Power over Ethernet injector, PoE. This concludes the external power connections. Now let's look at the network connections. The barrel travel router is what all of our electronics, computers, etc. connect to get Wi-Fi. This connects via a modified Cat6 cable to the PoE injector. The PoE injector then takes the signal from the router and injects 48-volt power on select pairs. This connects via another modified Cat6 cable to the RJ45 to Dishy converter. And the RJ45 to Dishy converter then allows us to plug in the standard Starlink cable. Finally, that cable connects us to Dishy, which connects to the satellite system. So another thing we're going to want to dive into now before we get started is the power over Ethernet requirements for Dishy versus standard. So I made a diagram for this too. Let's dive into that in a little more detail so we understand what we're looking to do here. There are some modifications you need to make to the cable in order for this to work properly. Let's start by looking at how a standard RJ45 connector is wired up. Please excuse me as I drew the first wire to the right, as that matches how I'm going to crimp them. Traditionally, the first wire is drawn on the left. The pairs that make up the data cables are ordered, each consisting of a solid color and that solid color with a white stripe, or sometimes the white with a solid color stripe. For the T568B standard, which is the most common, the pairs are ordered orange, green, blue, and brown. However, the pairs are not connected to the connector in this order. Instead, they are varied, as you can see here. Orange, white, orange, green, white, blue, blue, white, green, brown, white, and brown. Now let's shift our focus to the power over Ethernet details. I've colored the positive wires red in these diagrams and the negative wires green. Notice that the standard PoE provides positive voltage on the first pair orange and the third pair blue wires. The others are negative. Dishy is using a different scheme. It is putting power on pairs 1 orange and 2 green. But it is still expecting the data signals on the standard pairs. So what we have to do is route the inbound wires into the PoE to the correct locations so that they get power injected in them. And then we have to undo that on the way out of the PoE so the wires are in their standard positions. Basically, we have to swap the second green and third blue pairs as we enter the PoE so that green will get powered and blue will not, and then we have to unswap those as they exit the PoE so the data pairs are back in the correct places. I've drawn up, in standard form, with left being the first wire, what this is going to look like. It's important that both of the converted ends are what connect to the PoE. If you get the wires inverted, I don't think this is going to work. Okay, so for starters, I'm going to figure out how much wire I'm going to need to reach my power supply. I think I'll be good with about 4 feet on this. So the first thing we're going to do here is we are going to wire up this to the fuse, and then the fuse is going to run into the switch. Okay, I'm just going to use these simple closed-end crimp connections to make these connectors with. You could use literally anything. Probably I'd prefer something that was inline but this is what I've got handy right now, so I'm just going to do this. These are pretty good and they're solid. So now I can extend this piece in here. I'll probably have a little bit of extra left over. And then I'm going to extend this piece in here as well. This is the negative for this. And if we can get the crimp on this. Crimp it on there good. Give them a good tug. Make sure they're solid. So these are all on good. All right, so now I've got the power path. All right, I'm just going to connect these wires directly onto the tabs. I don't really have any connectors that are going to fit in there very well, but these should be okay. And then, let's see, this is the power source, so I'm going to bring that in to the off position, I think. And I'll leave that, put that in the off position here. And there is it's a clamp type connector here for this switch, so this should work pretty well. In here, common, I'm assuming common is the ground here, or C means ground. We'll find out. That's on there pretty good. This will be on the positive side. And that is on pretty good. So we've got the power coming into this system now through a fuse. The next step is going to be to provide enough power to reach the step up transformer now, which I think we're going to mount this way. I think this is what I've decided how I'm going to mount this thing here perhaps, and then I'll be able to reach these right around here. So what I need is probably about 4 or so inches of cable to reach this switch. I'll probably give it more like 5 or 6 inches just to be on the safe side. And then we're going to go ahead and strip these a little bit further. These look like number 12 probably to me. Might even be 10s. And then get this one a little bit further. All right. And again, I'm just going to use these crimp-on connectors here. good. These are all good there. So we're going to feed these in. Pull these apart and strip them as well. These don't need as much exposure because they're just not that far for them to go in. And so loosen these up. All right, those connections are all good there. Pull a little bit of the excess out of here. And again, this is waterproof, not necessary for this application, but that's just how it is, so that's what we got. Looks like that gasket is all properly sealed there. All right, we're going to tighten this up here. This will ensure, it kind of acts as a strain relief for these. I don't really, again, care about the waterproofness because nothing else here is really going to be waterproof, but this is going to act as a strain relief. So now we've got a fuse, we've got a switch, and we've got the next step is going to be our power over Ethernet. Now, I will say that the power over Ethernet has a little bit of a, there's a bummer in that it doesn't have any kind of mounting or anything at all to mount it with, which I feel like that's unfortunate, but I think we're going to be able to work around that. What I will probably do is I have some of this dual lock stuff, which is I don't know if you've used it, but it's incredibly, it's like Velcro on steroids. And I think I'll be able to use a spot of that back there, attach some of it to the board and some of it to the casing, and that'll work for us. So if you haven't worked with this dual lock stuff, I just cut it and made two little strips here. If you haven't worked with this before, it is super sticky. And I think it'll stick to just about anything, so I'm going to put it on the back of this and press it on for a little bit, and that should adhere pretty well. Probably a good idea to hit this up with some alcohol and clean it first. This one's pretty much out of the box, so I think it's gonna be fine. There's not going to be really any pressure on this once it's operational. There's nothing, you're not going to be connecting and disconnecting the Ethernet cable to this, so it's just static. All the other components have mechanisms to mount holes that we can put some screws in, but this does not. Keep some pressure on that. I think they recommend having pressure on it for a minute or something like that. You can shut it off. All right, so now we're going to take the output of the step-up transformer, so this will be 48 volts, and we're going to connect that to the power on the PoE injector. And you do have to pay attention, obviously, to where your positive and negative is. Coming out of the transformer, yellow is going to be our positive here. So, and I don't know if these cables are stripped quite as much as I would like them to be, but you're going to need a fairly small screwdriver to loosen up these connectors here. Fortunately, I've got a few of them lying around. So this connector does come out of the PoE injector, which makes it a little bit easier to gain access to. These are pretty tight, and the insulation in particular is pretty tight here. But I think if you can get that to force in, there's enough bite probably from the clamping mechanism to make a good connection. We'll give them a good pull and make sure that each one is pretty well connected. That seems well connected. They both seem pretty well connected, so now this will just plug back in here. So now I think is a good time, now that we have this on, to go ahead and figure out where we're going to permanently mount this guy. So our switch is going to be about here. It's a little messy, but this area up here is going to be tucked away in a corner, so I'm not too worried about that. What I do want to make sure is that I've got good room to plug the Starlink connector in here, and so I'm going to bring this over and just make sure I've got good clearance for that. So this is how this connector works. It's going to fit right in like that. So you got to make sure that you've got room to put it in here, and I'm going to have a wall right here close to the edge of this, so I'll probably bring this more over towards the middle, but that should give me pretty good access. I can reach that pretty well. So I'm going to mount this about right here. And that means that this can go here, this can fit right here. I think this is a good place for these guys, so I've cut a couple more of these here, the dual lock stuff. And again, you could mount this however you want. You could use some tie wraps, or there's probably dozens of ways you could do this stuff, but I'm going to do it this way. So I'm just going to eyeball this and say that should go about right there. Put this down, and this dual lock, another nice thing about it is it doesn't have to be absolutely perfectly located, because you have some slop in terms of how you can apply this to it. As long as it's got a little bit of purchase on that, it's going to be good. So I'm going to do this side too here. Let's see about where we need this to be. About right there. Yeah, that's great. Okay, so those are the main components. I'm going to go ahead and mount these on the board real quick, but I'm not going to bore you with those details, and we'll be back in just a minute. Okay, well, we've now got all the components are mounted down onto the board here, so they're all in place. They're not going anywhere. This board's going to mount into the spot I have for it just fine. In fact, I'll probably use the dual lock material just to mount that as well. It doesn't need to be screwed in necessarily, and I'm not sure I can get a screw into the area there very easily. But the next step that we've got to do is to make the cables for the PoE connector. Well, basically we need to make a cable for the router to connect, and also then for the PoE injector to connect to the Dishy cable. So let's refer back to the diagram here. We'll spend a little bit of time walking through this again to make sure we know which pairs need to be twisted properly, and we'll come back to this and finish it up. All right, so as we discussed earlier, Dishy has a specific configuration it requires for power over Ethernet, and it's non-standard. So in order to get that to work, we're going to have to put new ends on these cables, and we're going to have to swap a couple of the pairs so they match up with Dishy. We do that going into the PoE injector, and then we do that coming out of the PoE injector, so the data pairs are actually still in the correct order. They have to be, or it won't communicate, but the PoE will get injected onto the correct pairs. So basically we're just going to put a new crimp on here, our new end, RJ45 end, on the Cat5 cable. This is Cat6 cable, I think, and it's shielded, which I think is something you want to do because the Dishy cable is shielded as well. I haven't done this for many years, but it's pretty basic, and you can buy these tools easily on Amazon. They're not expensive. So we're just going to take off about 2 inches or so of the insulation off of this, and we just want the outer black insulation. We're not trying to get through to the sheathing underneath it to the degree that we can. You're going to get a little bit there, but if you leave some of that on, you want to fold that back so that it makes contact with the shielding in the connector itself. As you can see in the connector, these things are shielded, and there's some points here where it'll ground against those, and that's what you want to do there. Each of the pairs are shielded as well, so you just pull this foil off, and I just put the foil back there too for now. We'll trim it up later, but we'll just pull it back like so. We do each one of these pairs, and then we'll get them sort of laid out into the order that we want them to be. I'm not thrilled with this cable in terms of it doesn't seem like the twists are real tight on it from what I can see, and also the white cables for these that pair up are just pure white. They're not like green and white, and so that makes it a little difficult when you're dealing with it to figure out if you've really got the white pairs in the right order, because they're not really marked. But I think we'll be okay. So I'm referencing my my guide here, and what this is telling me is I want orange, white, then orange, and I'm trying to keep these things pretty straight here. And now this is where it's a little bit different. I'm going to go with blue. Normally you'd have green, white at this point, but we're going to run blue here because that's where we're going to need the power. So we go blue, and then we're going to have green, white, and green. So over here is my green, white, and then green. Then we need the blue, white, which I folded down here. And then we're going to go brown, white, and brown. And so what we're going to do is cut them off so that they're nice and even at the end. And then I'm going to get my cable, and we're going to feed it right up this way. So it's going to go like that. I'm going to try to keep these wires in the right orders here until at least they get far enough in. And then, okay, so we've got this fed through now. This is a through connector, so nice thing is that you don't have to worry about getting the ends all perfectly in alignment there or cutting them off, stripping them exactly right. And that allows you to kind of pull the connector down over the cable so that it's tight and there's not a lot of extra space there, which is important, especially with these shielded cables. So what I've done is the connector is not all the way back as far as it can go yet, but right now I'm going to try to cut off excess, the excess braid and shielding here. And then that way when I bring the cable down, there hopefully won't be much remaining that's poking out of it. And I'll just trim whatever is there. These dikes have seen better days. Now I'm going to push this down the rest of the way, and it's through. It's looking good. These guys, I just kind of tie them together a little bit so they feed through here more easily. And we're going to feed this through. Going to make sure all of the wires come through here. None of them get lost on their way. And now it's fed all the way in. And we just simply hold this, push this down. That's going to both crimp and cut the wires flush with the end of this cable here. So that looks pretty good to me. Oh, there's one ground wire hanging out here. I'm going to trim that off. And that looks pretty good. Let's do a quick test here. Okay, so we've got the cables, the crimps on, everything's all cleaned up now. I want to run it through this quick little cable tester that I have. And this is going to show me the pinouts and how they're connected. So I rarely ever use this thing, but in this case it's kind of handy. So as you can see when we run it, it's going to show that 1's through, 2's through, 3 and 4 are crossed, 5 and 6 are crossed, 7 and 8. And that's exactly what we're looking for. So this should provide the power correctly, or the PoE correctly. What you want to make sure is that you put the correct side of the cable into the PoE injector. It does matter which side you put in there. So we're going to put the side we crimped on the PoE injector. Now what's left to do is we're going to want to connect the power over Ethernet to the Dishy converter here. And it's important to note that we're going to connect the cable in that we crimped here to the power over Ethernet, because that's where we want the conversion to happen. So we're converting as we come into power over Ethernet, and then we're unconverting it when we come back out, because we need the Ethernet pairs to still be in the proper order. So we're going to do that, and then we're going to pull this up here, and this should, if I've done everything right, get us into the proper working order here. We're going to want to put the end that we crimped, or the piece that we manufactured here, into this. And And so that will give us the whole connection straight through. What we may do is just test our power here to see that the pins that we expect to have power do have power here. So I'm going to go ahead and get that set up. I'm going to set up my multimeter with some thin probes, so maybe I can test this out. I'd like to do that before I plug it into Dishy, because I don't want to, if the power is wrong there, potential to do some damage to the dish, so you don't want to do that. Okay, so I've got my multimeter here. I've got these special sharp tips, and this is not absolutely necessary, but I think it's a good idea. What we want to make sure is that we've got 48 volts on 1, 2, 3, and 6, and that we don't have 48 volts on 4, 5, 7, or 8. So I'm going to start by just using 8 as a reference here. So I'm connecting to 8, and I'm going to check pin 1, and I see 48.2 volts there, so I'm happy with that. We're going to check pin 2, and I see 48.2 volts there, so that's good. Let's do pin 3, and again we have 48.2 volts, so that's good so far. Now let's do pin 4. Pin 4 has nothing, and that's what we expect. Pin 5 similarly has nothing, and we expect that. Pin 6 has 48.2 volts, and that's what Dishy wants. And finally, pin 7 has no voltage. So I think we're in good shape here. Doing this makes me feel good about connecting this up to the dish. So our next step here then is, oh, and we also got to check our switch lights up properly, and I did put a 15 amp fuse in here as well prior to this. So I turn this off, and the next phase of the test will be to actually run the dish and to plug in the router and see how this is working. Here we are. This is actually the next day, and what happened when I started testing this unit is that with my regular Starlink cable, things were working okay, and I was able to get a connection. But I do have the 150-foot Starlink cable too. Sometimes we're in places where you might need to go quite a ways in order to get clear of tree coverage or something. And with that cable, I found that I was constantly dropping off the network. And what was dropping off was the actual link to my little travel router here. And what I surmised was probably happening is there was too much voltage drop, so that by the time it got out to the Dishy, the voltage that was 48 volts here was substantially lower. Now, unfortunately, that proprietary connector, I'm not able to measure the voltage on that. I'm not equipped to do that. But this was my assumption, and then as I read a little bit more, like for instance, you could join the, the Starlink Hacks Facebook group or one of the other online resources. And there was some indication that others had had a similar problem. So what I did is I went on Amazon and I bought a different step-up transformer, and this one is up to 56 volts instead of 48. So by the time you get the voltage drop there, we're going to be a little bit positive of 48. And from what I understand, Starlink themselves are actually running 56 volts. So although the standard's 48, it's tolerant of a higher voltage than that. So that's what we got. I put this in. Fortunately, it's the exact same form factor. Everything, it looks exactly the same. And also, prior to replacing this, I recrimped all of the cables that I had, just in the chance that maybe I hadn't crimped one well. That didn't seem to help, so I was pretty sure that the crimp jobs were okay. But that was the first thing to do, and I would recommend you do that if you have the problem. What indicated is I was able to log into the to this barrel router here, and it has an option for using WAN, and the WAN port would drop off, then it would come on, and it would maybe stay on for, you know, a minute or two, and then it would drop off again, and then it would come on. It would just continuously do that. It would never fully sync. When I used the shorter cable, I didn't have that problem, and so that's what made me think, yeah, it's probably voltage drop. Anyhow, what we're going to do now is run through the rest of the testing here just so you can see how that is, or what we did. Let me explain the cast here. This is just a little DC power station here, and I'm going to use this to simulate the battery that would be in the RV. And then over here, this is just a little portable battery, but it has a USB connector on it, so I'm going to turn that on, and that's going to power the router here. Normally that's powered through a USB connection in the RV. That's always on. So as we set this up, we're going to, let me say one more thing that I did. I decided that I would go ahead and install this XT60 connector here for power, because I think what I'm going to do with this is I'm going to mount it so that I can easily remove it from the system, and in doing so I want an ability to kind of unplug it easily too. So that was real easy, but I didn't want to show that. It's not germane to the actual setup. So we're going to take the end we crimped, and we're going to place it in the injector here, the PoE injector. This other cable, which I also rebuilt, is plugged in the same way with the end that was custom crimped on it. And then this is going to go into the WAN port of the router, which is right there. And now we're going to go ahead and fire this up, turn it on. All the cables are connected. Switch turns green. You can see now that there will be a little bit of a spike here in terms of power. This is the amperage being used. And what I find is that early on it'll go through a little spike where it will actually read up to 9 amps. I don't think I saw it go to 10 amps, but I have seen it go to 9 amps, and that happens pretty early on. And another thing that I've noticed is that the initial DHCP address that the router will get will be 100.1.1.100. I think that's it. Yeah, and so it gets an initial IP address. I think it gets that from the dish, and it's just a static IP. And then as soon as Dishy connects with the network and the internet, it's going to go ahead and assign it a regular IP address, which will be other than the one it initially gets. So there's about a 2-minute period or so where that's happening. Trying to get this to show up here. Reconnected to my house network here, so but as you can see, the power's kind of settled down now. Okay, I got to log into the router. And yeah, you can see there's the initial IP address that it's going to pick up. I don't know if you can see that. Do you see that? And then in just a little bit, this will pick up a different IP address. And if we go, you can load the Starlink app, and eventually, as soon as the system comes online, you'll see that you'll see that it says offline. And for me right now, this is because I don't actually have our dish activated right now. We're not traveling for the next month in a place where we're going to need Starlink, so I've got it turned off. But you can do all this and you can test that it's functional without Starlink being activated. It'll show offline, which is just fine. You can see now that I have picked up a different IP address. So now if you look at this, I've got an IP address that was assigned from the Starlink network. So, you know, even though I'm not active, I am still on the network. I just can't actually get anywhere. I was hoping the speed tests might work from the Starlink app, but that doesn't appear to work if you're offline. What does work, however, is you can determine your gateway's address in your router, and you can run pings to the gateway. So, and the gateway's up there, you know, I'm not exactly sure where Starlink has that. If it's on ground, probably that's on ground, but it runs through the satellite system. Maybe the gateway is up on one of the satellites. I'm not sure how they've got this architected, but you can see that the pings are working and this is functional. So I'm pretty happy with this. Now that it's kind of settled in, you can see it's using, interestingly enough, it's using 4 or so amps now. Earlier I was testing this and I was finding it was, you know, running between 2 to 3 amps, or maybe 2.8 to 3.5 on average. So, and that's going to be about what it is. So I've decided to simplify things quite a bit in terms of the router positioning. But here you can see this is the conversion board that I created, and it just mounts right against the wall here next to kind of the convenience center, whatever you call these things in the pass-through storage. And then I ended up putting the router, just mounting it using some dual lock right against the roof here. There's nothing up there, and as I found, the signal in the RV is just fine with a router here. So it's pretty convenient. I had some concerns if I needed to reset the router or something, that this might not be a good idea, but we've been on, you know, 35, 40 days of service now with this, and it really hasn't been a problem. So that's how we are. You can see the this cable for Starlink when we're using it. It's not being used right now, but that just simply runs straight down and then through the egress here, along with all the other pieces that would come up through there. It fits in quite nicely, and I can get this thing deployed in just a matter of minutes, so it's really convenient. All right. Well, anyhow, thanks for sticking with me on this and watching. I hope this has been a little bit of help. This, I think, is going to help us quite a bit in terms of what we need it for, and I look forward to using that. This is kind of for anybody who doesn't have my exact trailer. This is probably useful for you and where we're going to call it. So thanks again for joining.